Community College presents me, Alyssa Riley, the Pre-algebra Diva. We're going to use the textbook, Pre-algebra, an integrated approach by Lial, Westwood, and the publisher's Pearson, and here's the ISBN number. This is for my online classes for spring 2013. First, we need to start out with my handwriting. It's awful. This is my 1. This is 4. 7, that little line through it, and the Z or Z, if you're British English persuasion, a little Z with a line through it. Chapter 1, we start with whole numbers. Whole numbers are all the counting numbers, including 0. So 0, 1, 2, 3, on and on. Things that are not whole numbers are fractions, like a half, 0.35 or decimals, negative numbers like negative 22. So you'll get a list of numbers. Like this. And they'll be asking you, well, which ones are whole numbers? 0 is, and the 1 is. Not the fraction, not the negative, not the decimal. The next thing to talk about is place value. And this is on page 4 of the Pearson book. I'm too short. So here we have our place value chart. We have our decimal in the middle. The stuff on the left is what they talk about in chapter 1. The stuff on the right, they talk about in decimal in chapter 5. So if we're to the left of the decimal, we start with ones, tens place, hundreds, thousands, 10,000s, and so on and so on. To the right, when we get into decimals, it starts at the tenths place, then hundreds, thousands, 10,000s, and so on. The difference is we start with tenths here, not ones, and everything on this side has the THS on the end. So you're going to ask yourself, well, what can I do with this? Well, if you want to write a check. Let's say we're buying what should we buy? We're going to buy a race car for it's a low-end race car. So $280,972. So how do you write a check for this? 280,000. 900. We don't need to worry about the no sense thing. We're just learning how to write the words out from the numbers. I know, the racing is thrilling. Then we get on to numbers and what they call the number line. So we can use this to graph numbers. Right in the middle, 0. Going towards the right, you get more positive. Going to the left, you get negative. Logging numbers on a number line. So we have 3. So you just put a dot where the 3 is. This leads us into greater than, less than, or equal to. And we've all done this game before. Remember, greater than, whatever's the bigger thing, the mouth opens up to it. So between 1 and 4, 4 is bigger. If we had 3 and 3, it's equal. If we have Okay, two's bigger. We have these things like -4, -2. The one that's bigger is the one that's closer to the positive side. So the -2 is actually bigger. So that's all cool. You know it all before. I know you do. So then they throw this thing called an absolute value at you. That is anything inside of these little pipe brackets, whether it's negative or positive. The answer is the positive value of that. This leads into physics, where they have things called vectors, and they have a direction, and they have a value. This is just the value they're interested in. They're not interested if it's negative or positive. So they go back to this kind of idea. So the absolute value of -2 is 2. Compared to -7, the 2 is bigger. Make faces if you're a dancer while I'm doing this, huh? That brings us into adding and subtracting numbers. That's my hand sign. The easiest way to do it is to think money. You got $2, you add 3 to it, you got $5. You got $10 and you spend 4, you got 6 left over. If you're $8 in the hole and you get $3, now you're only $5 in the hole. If you're in the hole $4 and you spend another 2 you don't have, now you're in the hole for -$6. And then they have this one last crazy rule, I call the Dracula rule, where you have 2 numbers and there's 2 minus signs in between them. So 7 minus a -3 becomes a 7 plus 3, and that equals 10. So it's sort of like you got the stakes and you cross them to ward off Dracula. This is the only one you can't think of with money. It just doesn't work. But all the other ones will. There's one thing to talk about when you have these subtractions. Some people can't see it like that. They can see it like this. And your book actually tells you to change it to a plus minus, which confuses me. You can do it if you want to, you don't have to. So anytime you see a minus, you can change it with the plus minus. There's some interesting properties to know about addition. The first one's obvious. If you have something and add nothing to it, you still have the same thing you started out with. That's called the addition property of 0. You have commutative property of addition, which says if you have 2 numbers and they're added, you can switch them around and add them.
Okay.
So there's several properties with addition. The first one's called commutative. So if you have 2 numbers you're adding, you can flip them around and add them and they'll still come out with the same number. The second one is the associative property. So if you have more than the 2 numbers, you can add any in the sequence and then add the last one to it. So if we have 8 plus 3 plus 2, we can add the 8 plus 3 first and get 11 and add 2 and get 13. Or we can add the 3 and 2 first, get 5, add it to the 8 and get 13. Next, we're going to go on to multiplying, which is the sort of sister operation of addition. You usually started out with x, so 3 times 5, then it went to a dot. And here, from here on out, you want to get used to this parenthesis method. Sometimes they use 1, sometimes they use 2. All of them mean multiplying, and you get 15. The reason we get away from these two is this one looks like a variable, and this one looks like a decimal. So, get used to this kind. There's several rules for multiplying. Anything times 0 is 0. Anything times 1 is itself, so 6 times 1 is 6. And you also have, like the addition, the commutative property. So you could have 6 times 3 or 3 times 6, you're still going to get 18. And you have the associative property for things multiplied in a sequence. So you could do the 4 times the 3 is 12, times the 2 is 24. Or you can do 3 times 2 is 6, times the 4 is 24. Special to multiplication is this distributive property, and it's more useful when we get to variables. But you can also use it with regular numbers. So you'll have something in parentheses, 1 plus 2, and then on the outside you'll have a number you can multiply this whole thing by. So you're going to take this outside number, times it times the first number. So 6 times 1 is 6, then times it times the second number. So 6 times 2 is 12, add them together, you get 18. This is where things get hairy, and these sign things will kill you until you're done with math. If you have a positive number times a positive number, or a negative number times a negative number, you're going to get a positive answer. If either one of them is a negative, with the outside one and the inside one, you're going to get a negative answer. So if we have 6 times 5, that's a positive 30. A minus 6 times a minus 5 is also a positive 30. A 3 times a negative 2 is a negative 6. Or if we have the negative 3 times a positive 2, we get a negative 6. Moving on to division, which is related to subtraction. All of these are forms of division. You've got 2 divided into a divided by 2, and this fraction form, which we'll use from here on out, 8 divided by 2, always equal to 4. We've got some special rules for division as well. First is anything divided by 1 equals itself. So if you have 8 divided by 1, it equals 8. And the second one is anything divided by itself equals 1. So if we had 9 divided by 9, that's 1. It doesn't matter how big it is, it's still 1. The third one is 0 divided by anything equals 0. So if you have 0 divided by 22, that's going to be 0. The next one, and it's easy to confuse with number 3, is anything divided by 0 is what they call undefined. So 8 divided by 0 would be undefined. This leads you to things called limits that you don't want to know about just yet, but you'll get there. And we also have signs associated with this, which are related to the multiplication signs. If you have a positive number divided by a positive number, or a negative number divided by a negative number, your answer will be positive. If either one of your numbers is negative, your answer is going to be negative. So if you have 8 divided by 2, that's going to be 4. If you have negative 8 divided by negative 2, the negative signs cancel, we get a positive 4. If we have a negative 10 divided by a positive 5, we're going to get a negative 2. Or if we flip the negative sign down to the bottom and have a negative 5 instead of a 10, we're going to end up with a negative 2. Before we get into the most important part of chapter 1, we're going to talk about rounding. So if we have a number like 846, and I say, okay, I want to round to the tens place. We're going to go one number to the right of the number in question. So that, in this case, is 6. So if that number is 5 or greater, round up. So in this case, and these squiggly lines mean approximately, 846 is approximately 850. We round it up. Alternatively, we have something like 842. The number to the right, and we're still looking at 4. The number in question is less than 5. Round down. So in this case, the 842 is approximately 840. This works with decimals too, so if you had 6.39 and you're looking at this place, you end up with 6.40. The important thing to know when you're doing your homework is they call for this front end rounding. If they don't say a place like the tens place, they'll say front end rounding. So you'll have a number like 962. So you're rounding this number. So you're going to end up rounding to 1,000. This is the most important part of this chapter. Exponents and order of operations. the most important. So if you have a number like this big number to the base one, it's like the husband. This little number is called exponent. It's like the wife. The wife tells the husband what to do. So this 2 says, hey, 8, multiply yourself by yourself 2 times. So this means 8 times 8, which is 64. So if we start out with, we'll make a little chart of 2's because they're easy. 2 squared is going to be 2 times 2 is 4. 2 to the 3rd power, or 2 cubed, is 2 times 2 times 2, which is 8. If 2 times 2 is 4, times another 2 is 8. 2 to the 4th power is 2 times by itself 4 times. So it's 16. This does not mean 6. You're not times the 3 and the 2. This 3 is saying, hey, 2 times yourself by yourself 3 times. So don't do it. Don't chop your hands off, even to the computer. And exponents have sign things going on with them too. If you have something like this, this means this exponent applies only to the 4th. So you'll have 4 times 4 equals 16, and this negative sign is still on the outside. If, however, you have a negative number and all of it is raised to an exponent, this means a negative 4 times a negative 4. 2 negatives cancel out, so you have a positive 16. You'll notice that whenever you have an even exponent, you're going to have a positive answer. If you have a negative exponent, you're going to have, this part will give you the positive 13 times another negative. I'm going to change it to a negative number. Which leads us to our favorite thing. Operations. Parentheses, exponent, multiply, divide, add, and subtract. There's 3 different levels here. So the first level is parentheses and exponent. The trick is you have to remember to go from left to right. As you're reading this problem, if the exponent actually comes first on the left, you do it first before you do the parentheses. Once you're done with level 1, you skip down to level 2. Multiply and divide, which is also left-right. And once you're completed with that, you go to level 3, add and subtract, which again is left to right. So, let's see. We have something like this. We do the parentheses first. We got 8 plus 2 cubed. 2 cubed is 8, so we have 16. This one's straightforward. We went left parentheses all the way to the right exponent. If we had this, we're actually going to do the exponent first. So that's 16, 2 minus 1, 16 plus 1, 17. And this works with each of the levels. So we'll try a little more difficult one. follow us in. First thing you have, the important thing to note here that this parentheses, since there's nothing to do in it, is actually multiplying. So that in this case, there's no parentheses, so we skip it. So we go on to the exponent. So 6 times 6 is 36. Bring everything else down. As you go on, you can combine steps, but I'm going to go ahead and write out every step I can for you. So we've done the exponents, we're done with the level 1. We skip down to level 2, multiply and divide. We go from left to right, so multiply actually comes first. It's 6 plus 10 plus 3. Now, we got division in here, so we do it first. I know it's tempting to do 36 minus 3, but you can't do that, it won't work out. So we got negative 3 divided by positive 3, so we're going to have a negative 1. Now we just add and subtract left to right. So we got 16 plus 36 minus 1. 52 minus 1. Equals 51.
Whenever you're ready, we'll splice these together. Hold on. Go ahead. We'll cut it where it needs to be.
So after this first example, here's a bigger example that you'll see some in your book. You'll have this big thing on top, and then a line, and then a big thing on bottom. This is a fraction. The only thing you do different to solve this is you do the top separately, you do the bottom separately, and then you put them together at the end. So for our top, we have 6 plus 2 minus 15 divided by 3. No parentheses, no exponents, no multiply, but we do have the division. So negative 15 divided by a positive 3 is a negative 5. So 6 plus 2 minus 5. Then add and subtract from left to right. So 6 plus 2 is 8, minus the 5 is 3. So that's our top answer. Then we go to the bottom. So we got 10 squared plus 5. No parentheses. We do have an exponent, so 10 squared is 100. Plus the 5. No multiply, no divide. So we go add. So we have 105 for the bottom. So we put them together. If you want to find the decimal, you take the top number, hit divide, put the bottom number in, hit equals on your calculator, and you can find the decimal. There's a strange saying to help you remember this. Please excuse my dear Aunt Sally. So P for parentheses, E for excuse for exponent, sorry, and so on. If you can think of a better one, go ahead and use it. I think that's